Hi everybody. Inshallah today we're going to finish the Earth chapter, and our last topic will be about quick revision on the structure of Earth and the geological time scale. If you remember here, we have 4 layers of Earth. The outer layer was the crust, yes, followed by the mantle. Then we have the core, which is 2 main layers in the core, outer core and the inner core. Okay. There is a very important theory called Continental Drift. It was raised by Alfred Wegener. And Alfred Wegener, it's W, but it's the same like Volkswagen. Wagen also was W, but we say it V because he was a German scientist. He raised this theory. The theory suggests that millions of years ago, all the earth was one land, one big land, and by time, this land is broken up into pieces and drifted apart. The evidence of the theory that he said you will find that the shapes of the continents are fitting together, like you are cutting the same paper in different shapes. So if you put all the pieces of paper together, you'll make one big paper, the same like a puzzle. Also, he said that types of rocks and fossils may be similar in 2 different continents. It means like here, he said that this was the Earth, all continents together, all continents making one big land. There is no sea separating continents together. And he said, for example, you may find a fossil here in North America and the same fossil here in Africa. And when I say the same fossil, I mean, or the same rock, I mean same age. It happened at the same time. So this is weird because who moved them from between 2 different continents? And there's a sea. For sure they didn't swim. But according to his theory, Alfred Wegener, that if the Earth was one big land, so maybe the fossils were here, and by time, when the continents are separated and there is now ocean between them, so these fossils or rocks are separated between or divided between 2 different continents. But he faced a big problem that people asked him, okay, what's your evidence about the fact that they moved away from each other? And he couldn't answer this question. Until 1960, it means after 48 years of a theory, there was another theory, very important one, called tectonic plate theory. And in the theory, it explained Wegener's idea. It explained how the plates or how the continents moved away from each other. This theory is saying that the Earth's surface is made of large plates. Okay, the continents are considered as, and each constant is considered as a big plate. So we have large plates. These plates move slowly on molten lava underneath them, and they only move few centimeters each year. So you can't detect the movement. So this can explain continental drift theory of Wegener easily, because if we have millions of years and each year few centimeters are separating each continent from the other, so after many millions of years, hundreds of millions of years, we can see this shape. Yes, they can move away that far from each other. Okay. He said that this theory is saying that it's made of tectonic plates. The Earth is made of tectonic plates. And tectonic plates, here they said that each plate is made of part from the crust and part from the mantle, because the mantle is composed of, as you see here, some layers, okay? So if we take only the upper part of the mantle together with the crust layer, what will happen? We'll make a new layer called lithosphere. It's like a sublayer from both crust and mantle. This lithosphere is the layer that's making the tectonic plates. So each plate is made of a lithosphere layer, which means that each plate is composed of part of the crust and part of the upper mantle. And if you remember here, when we said that the volcanoes appear at the borders or the boundaries between the plates. Do you remember this? When we said we can find the volcanoes here at the border line between continents because they were the thinnest parts of the crust, and these are the part that the mantle can erupt from, making the volcanoes. Okay, so this may be making sure that the theory of continental theory and the tectonic plates theory are right, the sites of the volcanoes. Let's answer some questions. What evidence did Wagner have for his idea of continental drift? He said that the shapes of continents fit together, the types of rocks on different continents match up, the fossils on different continents also match up. Okay, why did some people reject his idea? Because he couldn't explain how the continents moved. Which plate do we live on? For sure, it's African plate. What is the connection between the plate boundaries and where earthquakes and volcanoes occur? We just said that. Earthquakes and volcanoes occur at the plate boundaries. Age of Earth. Scientists all over the years need to know the age of Earth, so they searched for the oldest rocks. They found them in Canada, and they found that their age was 4.2 billion years ago. But they thought that this may be not so much accurate, and that the Earth is as old as the solar system. So they tried to study some pieces of rocks called meteorites, and meteorites means fragments of rocks from space that fell to the Earth. And they found that yes, when they studied a meteorite, they found that its age was 4.5 billion years old. So maybe this is the same age as the Earth. And here are the meteorites. You'll find that it's falling from space like that, and then makes a big hole like that, and they take pieces of the meteorite and keep it safe here. Okay. After knowing the age of Earth, they tried to classify or dividing up the length of time between now and then into eras. This 4.5 billion years ago, try to put them into eras. Okay, 3 major eras, and each era is classified into periods. And this is just to make it easier, like when we classify year 7 into, like, this is year 7 and this is 7A, 7B, 7C, so we can know the students easier. The same here. This is the era, Cenozoic era. It's divided into Quaternary and Neogene and Paleogene. And these numbers are the numbers of the in millions of years. And here, Quaternary, it started 1.8 million of years ago till now. Okay, Neogene it started 23 millions of years ago till the beginning of the Quaternary one. Paleogene, the same, started 65 millions of years ago till this number of the previous period. So the total number of years here will be from, in this era, Cenozoic era, started 65 millions of years ago till now. Okay. In the geological time here, it's useful to know some information like some rocks, They started like coal and limestone. They were formed in the Carboniferous period of time. Also, we can know that chalk is formed in the Cretaceous period. Let's answer some questions. What era are we living in today? For sure it will be Cenozoic, because zero means till now. Zero means now, okay? The present. How long ago did Mesozoic era begin? How long ago did it start? For sure it will be 251 millions of years ago. Okay, it started here. In which era did Devonian period occur? So let's search for Devonian period. Devonian. Yes, it's here. When did it start? It will be for sure 416. Yes, it starts 416 millions of years ago, and this was at the Paleozoic era. So just why it's helpful to divide the Earth history into eras and periods. This is very useful for scientists to illustrate the order in which events on Earth have happened. It may make it easier for geologists and other people to think about them, or that it may be easier to remember names rather than just ranges of dates. Thank you.